Of the okay. Uh, Welcome to part two of managing the fugitive dust on roads and airports. If you remember in the first portion of it, why is it not moving forward? Um, okay, I remember in part one we talked about some of the lower cost methods of road dust management. First, we talked about what dust is and why we were concerned about it, the impacts of dust, and the methods of managing the dust in a number of different ways. Of course, always one thing that we always want to do is prepare the road for the application of palliatives. And we talked a bit about selecting and applying those palliatives, primarily things like uh, uh, calcium chloride, water, and synthetic fluids. And then we talked about how we can measure the performance of, uh, of the palliatives themselves. In this part of it, we're going to talk a little bit more about some of the higher end um, methods of managing dust, including the use of clay additives, polymer stabilizers, chip seals, recycled asphalt, and the holy grail of dust management, which is hot asphalt pavement. Okay, just kind of reaching back a little bit. The gravel surface, sometimes we call that an unbound surface material. And those really work well for an average daily traffic of under 800 vehicles per day. It's less expensive than we might see if we use pavement, easily repaired, mostly grading and adding a little bit of surfacing material at times, and the equipment is relatively available. Disadvantages is that it requires maintenance, usually typically on a monthly basis. In some, if it's higher traffic, perhaps more than that. It can get rough. It's when it's dry, it gets dusty. That's one of the reasons. Well, I guess that's the reason we're here. And then if it's properly maintained, it can become muddy if you don't provide the proper drainage for that. Let's talk a little bit about clay. Clay is a very good palliative, as it turns out. We've used it uh, when I was working for DOT and a number of times, and DOT is going back to that on the Hall Road with some experiments they're doing, I think, this summer. Um, Remember that we're looking for gravel surface course to have about 8 to 15% fines by weight. But one of the things we can do, oops, there's a typo there. If we replace between 4 and 6% by weight of the material fines with bentonite, montmorillonite, that'll reduce the dust for the life of the surface because we're going to mix that clay in with that uh, aggregate throughout its depth. And so if you put 4 inches down, it'll last the entire length life of that 4 inches. So that's pretty attractive. As far as grading goes, nothing really changes for you at all. And so that really makes it quite attractive. Um, Clay, like salt, is hydrophilic, but it acts somewhat like a sticky glue. That we call that cohesion, and it binds the surface together, and you should get a lot better performance out of it. Fewer gratings on that, and one of the nice things about using clay in the surface course is it tends to set up really hard and gives a nice smooth surface, and in some cases it appears almost like a pavement. But we also want to be a little bit careful. If we use too much, it'll turn to mud, and since it's hydrophilic and really wants to hold on to the water, too much of that will make it muddy, and it'll also make it where it tends to rut really bad. So that's you got to find that sweet spot in there, which tends to be somewhere between 4 and 6% by weight uh, of the aggregate. Uh, Basically, it's pretty straightforward. You can mix it in the stockpile, if you will, as it's being stockpiled. You can put it in as it's being loaded into the truck, or you can apply it on the road with a blade mix. If it's on the road, you probably want to windrow the surface, add clay to appropriate rate, and then blade mix that. Add water, compact. Very uh, in some cases, much like working with calcium chloride. You can either purchase it in 80-pound bags or in super sacks, depending on what you're capable of handling. Each of them have those advantages, and you probably want to think that through a little bit as you go through it. You certainly want to start with a reasonably good material in the first place. The photo that we're showing here, which was in Unalakleet, they didn't use clay, they were paving, but you can see that there's a lot of segregation in that and larger size rock. That probably wouldn't be a good choice uh, for the use of clay. You probably want 3/4 minus material. It does not necessarily have to be crushed, but crushing does make it more stable. Okay, let's talk a little bit about polymer stabilizers. Those are good for less than 1,000 ADT, average daily traffic, and these can last 5 years or more. In fact, it's somewhat like pavement. The nice thing about these polymer stabilizers, they do come in a powdered form, so all you have to do is keep it dry. You can let it freeze. But if you decide you want it in the liquid or emulsified form, uh, please do not allow it to freeze. You want to hold it in warm storage somewhere so that it cannot freeze. Otherwise, you'll lose it. And we tried to put it back into solution, and we're not able to do so. Um, if this is one of the projects that we worked on a number of years ago down by Wasilla. In this case, it came by totes. We pumped it into a water truck and then applied it from that vantage point. Here's some a little bit of data that we collected on there. Uh, that was in the case of Horseshoe Lake. It was blow sand, wind-blown sand uh, in there. And we were able to get unconfined compressive strengths of about 1,100 or so. We did it correctly, but more commonly, we were able to get around 800 with all of the products. Uh, just to put that in perspective, a standard concrete is about 3,000 psi. So it's between a third and a half the strength of concrete. Sets up really hard, makes a really nice surface on that. And at Horseshoe Lake, this is what it looked like a year after we put it down. It had not ever been graded during that time. The last time I looked at it, it was about 6 years old, but I was talking to some folks from Matsu Borough. They said it's still there, still in service after about 15 years, but it is getting a little bit ragged, and they're looking at replacing it at this point. But it did not work out pretty well. The downside of it is if it potholes, you have to repair it without grading, and a lot of people just use a bucket and mix it in with the sand or the aggregate, and then pour it into the hole, compact it, and let it set overnight, and it will set up for you. So it is a good product. We are using it, starting to see it used more and more over time, and it does work, but it is, as we can expect, a little bit more expensive than some of the others. So basically, what I've been doing is going from the cheapest to the most expensive, and so we're still going along that path. So it's sort of in the middle as far as cost goes. But it does have to be designed. And if someone's interested in using that, I can work with you to develop the right mix of the polymer and the soil that you're intending to use. This is another example from a trip that I took to Arizona to look at polymers a number of years ago. And in this case, they just simply applied it on the surface, and they were spraying it on about once a year. And they were not having, they'd been there, this road had been there a couple of years without any grading on it. It is a little bit cheaper than, quite a bit cheaper than the way we did Horseshoe Lake, where we mix it in down to 6 inches. So you can either topically apply it or you can apply it to depth. Okay, let's shift gears a little bit and talk a little bit about recycled asphalt. Um, the asphalt right now is 100% recycled, um, in one form or the other. DOT does everything from mixing in to the existing base course to mixing in the hot mix, but sometimes we have extra material and we stockpile it, and we can use that recycled material as a surface course, which is provides a low dust surface. My driveway is made with recycled asphalt, and all they did is treat it like gravel, basically. Put it down, roll it, spread it out, and then compact it, and it will hold up for quite some time. My driveway is about 6 years old now, with that surfacing material, no dust, and it's really kind of nice to be able to be out there and working around the yard without dust coming off of my driveway. There's a lot of ways you can put it down. You can treat it like gravel and just simply lay it out and compact it and go that way. Some people actually add a fog seal to it. Those who don't know what a fog seal is, you add about 1/10 of a gallon per square yard uh, of emulsion, usually, to that surface, and it helps bind the surface together a little bit and help seal it. Works pretty well. There's another technique called warm mix asphalt, where we basically take it back to a plant and add emulsion or heat the rock up to about 100 degrees Fahrenheit, and then add emulsion to it and take it out and put it on the road, and that works out pretty well. And the final way of doing it is just mix it in place with emulsified asphalt. Uh, we did that down on the Richardson Highway, just south of Copper Center, uh, a number of years ago, and that worked out really well for us. And then chip sealed over the top of that. But you don't have to start out to chip seal in low volume road. Works out really. The problem with the recycled asphalt is it's really gotten hard to obtain. It's so popular that people are standing in line to get it. And so if you're lucky and have a resource or have access to it, it's a good a product for you. I apologize. I got a little bit of a allergy going on here. Let's talk about paving. Paving comes in a number of different forms. There's chip seals, high floats. We usually aggregate those into one. And of course, we've got hot mix. And so this is used for the higher volume roads, typically over 1,000. Some people pump that up a little bit, but it's somewhere in that range. These are some good resources for you. The soil stabilization manuals goes over a lot of ways to improve your aggregate and your surfacing. The asphalt treatment guide uh, goes into the details of putting down either chip seals or high float, and gives you all the details for that. And for the high end is the Alaska Flexible Pavement Design Manual. It's got two methods of designing your pavements. But when you start getting into these sort of products or surfacing, you probably want to hire an engineer to work with you, because they get fairly complex, and the analysis gets to be, and the testing gets to be complex, and it's just better to get somebody who's an expert in that area. Let's get this. Why should we consider paving? Well, of course, our discussion here really centers around reducing dust. and paving does a nice job of that um, most of the time. Uh, it also reduces operating costs by 10 to 30% over gravel, and it takes less frequent maintenance, but the maintenance that you do have to do is often more expensive. It is expensive. A unit of cleat, which we see here, uh, 10 years ago, cost $3 million a mile. It does require a much stronger roadway surface, and we'll talk about that here in just a moment. And as I said, it's more difficult to repair. One of the downsides that many communities that have paved have talked about is it does encourage uh, greater speeds, and you have to figure out ways to manage that. One of the things I will say about paving is you really need to control where people get on and off. If you go to in uh, Nome or Utqiagvik, people get on and off the road wherever they want, and they track the mud on, and the road looks more like a mud road or a gravel road than it does a paved road. And when that dries out, you get a lot of dust coming off of that. So I would encourage you to look at channelizing the traffic and how it gets on and off. The characteristics of a good surface course is it's resistant to abrasion, resistant to cracking, waterproof, smooth, quiet, of course, dust-free, and it survives the environment. And you want to make it as inexpensive as you can make it. So trying to balance all of these is quite a chore, and that's what our engineering community is skilled at doing, and that's why we have those manuals that we work with. I just showed you a little bit about the terminology that we use as far as that goes. The surface course is always what where the traffic hits the road. Uh, it's the portion of it that the tires see. And then beneath that, we have a base course in there. It can be either crushed or it could be another layer of asphalt. The sub base course is placed on the subgrade to support the traffic. So the purpose of the pavement structure, it's the part that carries the weight of the traffic, and it's we'll talk about how it does that in just a moment. Okay. Um, so the surface course, as we said, supports the traffic and the pavement structure, and then the subgrade, that's is beneath the pavement structure, is the part that supports the pavement structure. So about the top 34 to 36 inches or so. If it's heavy traffic, maybe a little bit lower, higher than that. That's the part that you have to design to carry the weight of the vehicles that's on it. And below that, you design that subgrade to be able to handle the weight of the pavement structure. As far as the subgrade, it really doesn't feel the weight of the vehicles at all. It's spread out to the point where it's so low that it becomes inconsequential if you've done your design properly. So let's talk a little bit about stress distribution. The surface reduces the load to the base course to a level the base course can support it and perform as we want. The service course really takes a lot of the load um, and spreads it out very quickly because it's bound together, and so it acts more like a semi-rigid material in there. And then we add to that to reduce it a bit more. We add the base course, and the purpose of the base course is, like the surface course, is to reduce the load on the sub base by spreading the load even further. And that you can do both of these either by using a stiffer material or you can do it by increasing the thickness. And we do both. It's really economics drives which way we go. And so sometimes we thicken it and sometimes we um, add a stiffer material in there. And it's up to the designer to figure out how to do that. And then finally, we take um, The subbase is either thick or stiff enough that it limits the subgrade stresses on the subgrade to a point that it can take it. So this whole process is all pavement designs are done like this, uh, no matter how complex they are. And generally, we call that a subgrade protection model. So we're trying to reduce the stress on that subgrade to a point where it can handle it. As I said, it's best to hire a pavement engineer if you're going to go with pavement to make sure that you get it right. As I said, we're talking millions of dollars here in order to do that. And I would suggest that uh, you certainly don't want to waste your money and by making a mistake. Okay. The other part is we really want to make sure that we pay attention to drainage. This is a photo down in the Matsu where they put a chip seal down. The drainage got across the road, it softened the base course, and all the money that they spent on that nice chip seal ended up being damaged, and they had to come back and redo it. And we've talked about drainage throughout this discussion, trying to reinforce that drainage is critical to everything you do. But once you start putting hard surfaces on there, um, it becomes even more critical because now you're starting to lose pavement that's very expensive surfacing, and you have to replace it fairly quickly, and that you really don't want to do that. Okay. So let's talk a little bit more about chip seals, and you would use those when you've got greater than 800 vehicles per day or less than about 2,000. It's relatively inexpensive, and you're just putting down the road structure, and then you're adding to that a thin layer of asphalt and aggregate course on there. You typically get about 3/4 of an inch of pavement thickness out of that, so it works pretty well. It's fairly smooth, waterproof, fairly easy to repair. And of course, what we're talking about here is dust free. The disadvantage of it, it adds no strength. If you remember the graphic that we showed just a moment ago, where the pavement surface is reducing the weight of the vehicle or the stress on the vehicle on this base course, you don't get any of that out of a chip seal. And so your life expectancy is between 5 and 7 years. But one of the things that we found in the work that I was doing with the Matsu Borough a number of years ago was that if we fog seal it with either an emulsion or something called gilsonite, which is a naturally occurring asphalt out of Utah, that we can oftentimes double that life just by giving it a little fog seal about 2 to 3 weeks after uh, we put the chip seal down and we broomed it and give it a little time to cure out. And Montana does that on a routine basis. They just simply put their chip seals down and let it cure out a little bit and then fog seal it right after that. And that substantially increases the life of the pavement. In fact, some people can't tell the difference between that and hot mix just by looking at the surface. They have to get down close to it to understand that. But it is limited to fairly low volume roads because it has no structural strength. Something to keep in mind. But in many of the communities, that's okay, especially um, some of the lower volume roads. Why? Who uses it? Uh, it's very popular in a number of countries. New Zealand is all of their roads are chip sealed, and I had the opportunity to drive a number of those roads a few years ago, and it's pretty amazing what they are able to do. Um, Most people driving those roads would think they're on hot mix, and they do perform very well. Canadians use chip seals for less than 700 ADT. Common Australia uses it for less than 2,000, and I expect that's because of the differences in climate. And France uses it for ADTs of less than 3,000, and Saudi Arabia are less than 500. So we're seeing that chip seals used on a worldwide basis. So I wouldn't be afraid to use it, but we will need to make sure that we do it properly. As I said, the life expectancy is about 5 to 7 years. We can double that with the use of fog seals. Usually, I like to use about 6 inches, 4 to 6 inches of base course over our sub base. That increases the life a little bit, and we have fully a number of chip seals around that were designed to state standards that have lasted 10 to 12 years or even beyond that. So it does work pretty well. But again, we're assuming that we have good pavement structure and good drainage beneath in those areas. High float is a slightly different method of chip seals or asphalt surface treatments. It in most cases it acts very much like a chip seal. It looks like a lot like a chip seal, a little bit rougher in most cases. But the nice thing about it is the cover coat is D1 instead of chips. And so, or very similar to D1. We actually remove a little bit more of the fines out of it, and it works out very well because of that. You have to be a little bit more careful. It's a little bit slower to cure. It does produce a little bit of dust in the first few weeks, which some people complain about, and it requires a little more expertise. The Canadians use it a lot. If you go down in the Whitehorse area, you'll see a lot of that. We here in Alaska, I use it a lot for patching materials over permafrost areas. If you drive the Richardson Highway or the Alaska Highway, you'll see a lot of it. We have some on the Dalton Highway, and it does work reasonably well. So that is another option to you. A little bit cheaper than the chip seals, especially where you don't have very high quality chips, and you can use D1 instead. But it does take a different emulsion, so you want to make sure that you get with a materials engineer that knows about these things and get their expertise on that. Hot mix asphalt. This is kind of the holy grail. Uh, People really like to see hot mix asphalt. Um, it's got a long life to it. Typically, the state designs for 15 years, although you can get to 12 to 20 years is kind of the average. I have seen some last as much as 50 years. The Alaska Highway, uh, the, the first time it was paved, lasted over 50 years. It's smooth. The public accepts it. They kind of expect it. And of course, it's dust free, provided that you don't get a lot of track on of the mud from adjacent land areas in that. This one, again, is at Unalakleet. Uh, One of the disadvantages of that is, of course, it's expensive. It requires a good payment structure. So that's sometimes where a lot of the cost comes in. You actually have to make a stronger, well, you usually have to make a stronger road than you would perhaps use as a gravel road, expensive repair, and usually want striping. In Unalakleet, they recently decided they need to replace their their utilities, so they lost some of the asphalt. And I don't know if they replaced that with asphalt as part of the project or not, but I would like to, I'd like to get an answer to that one. But it is very well accepted, and it will perform very well. One of the things we see with hot mix in the villages, communities it goes into, is that we see kids out on their scooters enjoying the smooth surface. We actually see handicapped folks in their wheelchairs out on the roads and moving around the community where they otherwise would not be able to with a gravel surface. So it does add a little bit of a little bit to the community as far as mobility of many of the folks on that, not just simply the motorized vehicles. So um, this is kind of a bit of a summary of what we've been talking about here. Um, the the chart on the left side sort of gives you an idea of the average daily traffic for those different types of materials and on there. If you've got a gravel surface, even though you're adding calcium chloride or perhaps synthetic fluids or what other powders you're using, you're typically limited to about 800. That's not a firm number. You could bounce it up. I've seen people bounce that up to 1200. The polymers that we talked about, or clay, about 1,000, although some people bump that up to 12 to 1,500. Chip seals, some people start at 1,700, even 3,000 we saw in France, and go up about 1,000 in the ADT. And of course, anything over that, we can use 2,000 or more. Uh, we typically use hot mix. Uh, we typically, for low volume gravel roads, Paladins work very well for us. Uh, Calcium chloride and synthetic fluids in Alaska tend to be the most prevalent palliatives that we're using, although there are others such as lignin sulfonate, which can work pretty well. Um, and uh, Water is always a good one. And then there's the enzymes out there, as well as some of the products that are produced out of a crude oil. Um, we also have polymers and clays. That's gaining traction over time. We're starting to see a bit more use of those as time goes along. Um, Especially in areas where you want the longevity that those materials offer. Uh, Polymers are a little bit problematic because of grading. If you grade it, you get to start over. With clays, the nice thing about it, as you grade it, you pretty much treat the surface as you would otherwise, but it does give you a material where the water runs off and very low dust as far as that goes. Chip seals or surface treatments work well if applied correctly. And that, the workforce that you use to produce chip seal has to be well trained. The equipment that they used has to be in good working order. So you probably don't want to do it yourself on that. You probably want to hire an experienced contractor to do that, unless you want to take the time to develop that expertise. Hot mix works well, but it must be designed. Hot mix comes with a lot of equipment. You have uh, your lay down equipment, all your rollers, your hot mix plant, uh, in all of that, and loaders to service the hot mix plant. So that makes it really expensive to use. The last number I got out in Nome was about $600 a ton. I think it's running around 200, 250 here in the interior. So it is quite expensive. And as I say, you want to make sure that you design it and that you hire experienced crews to put it down. So with that, I think we're about the 40-minute mark. I'd be happy to answer any questions. And if, let me see if I can turn the chat on here. Okay. I don't see any at the moment, but if there are any questions, I'll be happy to answer them.
People can raise their hands, post questions in the Q&A, or post questions in chat. All right. Well, if there aren't any questions, thank you all for joining us today. I will stop the recording.